Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA, and your host on the Clinker Factor. Today I'm talking to Andreas Sichert, CEO and co-founder of the clean tech company Orcan Energy, who are a leading manufacturer of waste heat recovery solutions, a little bit different from the traditional waste heat recovery we find in the cement industry, and we'll get into that in a moment. Also joining Andreas is Markus Lintl, Head of Industry and New Business at Orcan. So Andreas, Markus, welcome. Andreas, if I could start with you, perhaps you could give a brief introduction of yourself and how you came to be working in this field and found Orcan Energy.
Hi, Jan. Thanks for the nice introduction and for the opportunity to join your podcast. So my name is Andreas. I studied physics at a technical university in Munich, and I also did my PhD there. And by doing that, we were looking for some technical innovation that will help to shape climate change and to contribute to that. And we looked into different potential innovations at the technical university, and we found that there is a very interesting development going on, how to build a very small scale ORC system. And we thought that this would be a great starting point for a company, because we saw that looking a little bit into waste heat recovery, that there is a huge market out there, potentially the largest energy market, which is untapped worldwide. And it is untapped because there is no technology out there to really tap into the small scale waste heat sources, which are the backbone of this huge market. This huge market consists of small and mid-scale sources. So that's where it all started, and where also my two co-founders, Andreas Schuster and Richard Aumann, joined me starting the company. And yeah, it was an interesting ride from the beginning to where we are today.
Thank you, Andreas. Markus, perhaps you could also give us a brief introduction.
Of course. So thank you, Ian, also for having us here in your podcast. My name is Markus Lintl. My background is a mechanical engineer. I studied at the Technical University here in Munich. From there, actually, I joined Orcan directly, starting as a student, making my way through Orcan. As Andreas already said, it was a quite interesting journey over the last years. Within this, I moved more and more into the sales and realization department, in particular in the industry sector, which, as you might know, is one of the key segments of Orcan, where we identified key customers like BASF, but also E.ON and others in the cement industry, which you might know about Cemex and others, where we both sold the units and installed them and are operating them quite successfully, and are looking forward then also to the next projects in those industries.
Okay, great. So we'll get into a little bit about the technology and how it's different from what we've already seen in the cement industry in a minute. But Andreas, perhaps you could give us an introduction to Orcan and its history and what stage of development you're at.
Sure. So we started the company in 2008, shortly before the financial crisis broke out. So we stayed a little bit longer at the university to mature the technology platform. Then we moved out of the university in 2011, and we entered into the biogas market, because at that time there were more than 8,250 remote located engines in the field here in Germany that are producing with more than 50% of conversion efficiency waste heat, which was not tapped or used at that time. So we sold several tenths of units into the biogas market, and then we moved to industrial applications. We started also at that time to look into it in Asian market, because it is a booming market with a lot of development going on there in different market segments. And then in 2019-20, we focused back on Europe, and with a lot of momentum from the Asian market and the success we have achieved there, we started in the geothermal market and on other industry markets such as metal processing and also the cement industry. And parallel in doing that, we also took care that we always have something a foot into the marine industry, because in the marine industry, where we are transporting our goods from A to B, there is an engine behind each ship, each large ship that is propelling it forward. And this is also producing a lot of waste heat. So reducing the fuel consumption there does also make a lot of sense from different angles. So that's basically where we are. We now have more than 600 units in the field, a lot of operating hours, a lot of different customers and different verticals in the industry. And we are now trying to scale up the business more and more each year in different areas in the world, and having not only a standardized product, but also offering full solutions for our customers.
So can you explain a little bit about the technology and what's different, your technology, from the traditional waste heat recovery, and perhaps why that's relevant to the cement industry?
Sure. So initially, I said that the majority of the waste heat sources that makes this huge market is of, let's say, a small and mid-size. So there are only a few sources that are 100 megawatt in waste heat source at a single spot. So the majority of the waste heat sources are in the single or lower two-digit megawatt scale. So that consequence that you need technology that is producing, let's say, 100 to 1 megawatt per unit. So you need smaller units. That's, I think, number one. Number two is we saw there was a race about high conversion efficiencies, but at the end of the day, the products or the solutions got more and more expensive, and not in the same way the conversion efficiency has increased. So the products got more and more non-economically viable at the end of the day. And what we try to do is to not too much focus on conversion efficiency, but on capital efficiency, to have a very economic, reasonable product at the end of the day. And I think it's very important to say it's a product. So take really the basis of, let's say, the ORC technology, but from the power plant scale, and bring it down to the, as I said, 100 to 1 megawatt scale, and having a simple product where everything is included. So we are currently selling a 20 and 40 feet food container where everything is included, from recooling, pumps, everything, power electronics. That makes it very simple for a customer. This building block, if you may want to say, does not only mean it's easy to install one, but you can also install several at one side, and this gives you flexibility. These modules and the modular solution gives you flexibility. And I think that is what is key currently for the cement industry. Because if talking to different players in the cement industry and our customers here, what we hear is that there's, of course, a big pressure on to decarbonize the production processes, right? The cement industry would be, I think, CO2 emission country number 3 worldwide if it would be a country. So there's a high pressure to come down with the emissions. But it's not 100% clear how this should be done at the end of the day, because it has to be done under a high pressure on the financial performance at each plant. The technology pathway is also not 100% clear. The only thing that is clear, I think, is to really decarbonize a cement plant, you need also carbon capture and storage technology. But what kind of carbon capture and storage technology will make the race? Some of them will consequent that there will be more waste heat available at a cement plant, and some of them need waste heat to function. That means there is less heat available. And you also have the ideas of having different fuels for the kiln. Some of them need drying or extra treatment, which also requires heat. And here in the northern part of Europe, we try to use the heat from the industry also for heating purposes. Of course, this is not perfectly synced in line with the annual standstill of the cement plants, but nevertheless, maybe you can use some of the heat for, 1,000 hours a year to sell it directly to heating grids, if available and applicable. So I think there are many scenarios out there, and with a modular solution, you can stay flexible, but at the same time do and make a decision now, and you still stay flexible towards the different future scenarios, right? So I think that is the advantage that we can bring to our customers with a simple product approach.
Adding this, of course, the modular and flexibility is, I think, the key advantage, or is one of the key advantages. Maybe to highlight as well, it's still, as you mentioned, it's a power plant, and we're having power plant technology in there, but at the end, it's also very easy and comparably easy to operate, for example. So there are no consumables, so we don't need water or anything else to operate it. All the electricity we need, we use directly from our generated electricity. So there's only one cable, for example, to connect to the grid. We have super low maintenance, so only once a year, 1 day per year, just almost nothing. Completely the operation is autonomous, and we react also on different load changes, which makes it very easy also to handle in a very complex process industry or in a big cement industry. And as mentioned from Andreas already, I mean, at the end, we are producing the entire power plant in a production site. In our manufacturing site, we test it and then deliver it to the customer, which of course reflects in a high quality standard. So we are not building or engineering on site a power plant with all welding stuff and whatever. We are doing this in a safe and secure environment in our manufacturing site. So I think these are general advantages, but which we see that reflect a lot in the customer's feedback as well, that this is definitely helpful and necessary at the end to entry.
So what I'm taking away from that is, first of all, that customers who are using your technology are buying a car, they're not building a house, which of course is much easier to do, right? Secondly, is the whole flexibility question, the fact that it's modular and that you can scale it according to your needs. And then the third thing is that the whole business model is driven by consideration of economic feasibility rather than absolute efficiency. And I think this is actually very consistent with the philosophy that the cement industry has had for the last 25 years. Because of the very high carbon intensity of the industry, we have to look at the economics of everything. We're not in a position as maybe the software industry might be of being able to say, okay, well, we can afford to spend money without a return just because of the size of the emissions. And so the actions that have been taken in the industry with alternative fuels and waste heat recovery and reducing clinker factor, improving energy efficiency, have all had to have a payback. So I think that's very consistent with the philosophy of the industry. You have a recent example, I think, with Titan Cement of a partnership that you put together. Perhaps you can talk a little bit about that to illustrate how your technology can be deployed in the cement industry.
Yes, of course. So we are not only OEM of products we are offering to the market. We started a few years ago to also offer solutions. That means we're taking care also for the installation part of it. That means the heat exchanger that has to be integrated into the processes, not only in the cement industry, but also in the cement industry. And we're doing that together with experts in the field, EPC companies that have been working in the cement industry for decades. So we are not, I think, arrogant in saying we know everything the best. No, we want to work together with the best to at the end of the day deliver the best result for the customer. So we are general contractor. We developed to really offer the full solution, having one face to the customer. And with Titan, we're going the next step. We really want to be a partner of our customers. That means we're looking together to different heat sources in the cement industry, different sites, especially interesting for multi-site customers. And then we are developing a concept how to best address that, different waste heat streams. And then we are also prepared to really operate the units and own the units so that the CapEx burden is with us and not with the client at the end of the day. And this really pays into this flexibility approach and this offering that even if there is some, let's say, modification of the plant due to the fact that we can easily shift one unit from one place within a plant or between plants, because it's always the same building block, the same unit, really can support our customer here and can make that happen. So without a big loss of money. And I think that also gives this extra element to flexibility, to de-risking, to making really a decision in a step into the right direction, even that not everything towards the future is clear. And that will not be the case the next years, right? So we will not have everything on frame conditions clear. But with these kind of partnership models that we are now entertaining, this, I think, is a big stepping stone forward.
So in these models, do you charge per kilowatt hour? Is that the sort of charging model, or is it more complicated than that?
Well, that depends a little bit on different legislation. If you do, let's say, something like a lease or something like a per kilowatt hour model, if there are extra fees, that depends really a little bit in which country you are. And of course, what kind of pricing and additional expectations our customer has. It is clear if you're shifting uncertainty from the customer to the financial market, which providing money for that, then the cost of capital is going up, of course. But if you can find the right balance here, then everyone can have a really nice business, good advantage for all involved.
Right. So I know you're involved in lots of applications other than cement, including transportation, which obviously is very important for cement. Would you like to talk a little bit about the other applications that you're applying your technology to?
Sure. I think Markus can tell you a little bit more about different industry applications. Maybe I start with our two other verticals and segments. First, the one is marine. We are equipping more and more ships with our waste heat recovery technology. That is one of the technologies that can even today reduce the fuel consumption of ships by capturing the waste heat of the main and auxiliary engines. We're doing that from inland waterway ships to the big seagoing ships, and that's going well. And from this year's onward, you have also from the International Marine Organization a pressure to constantly decarbonize the ships that you are using. It's also important for the supply chain for different industries that these ships are becoming greener and greener. I think we can help that, and it is again with a payback. So everything that we do is profitable at the end of the day and is reducing the CO2 footprint. Then the third leg in our company is the power segment. That means we are tapping into the waste heat of traditional power assets, such as gensets or gas turbines, for example. If we look, for example, into the Middle East, we find a lot of cement plants that have on-site generation. They're producing their own electricity that they're using by means of large engines or gas turbines. And this, of course, is also a good starting point for increasing the energy efficiency there, because legislation and regulation is moving towards high energy efficiency also in these kind of regions. And this holds true, as I said, from I would say Alaska to Southeast Asia, that more and more energy should not be wasted but used. What we also consider as an application in power is geothermal. We have more and more projects where also this modular approach is beneficial for geothermal developers, because the drilling risk is significantly reduced if you have the ability to quickly react to different heat that is coming out of the ground. Also, the risk of changing heat over the lifetime is reduced. And we also can upgrade existing plants, flash plants, for example, in the geothermal world to make them even more efficient. So these are the segments, power and marine, next to industry. And Markus, I think, is the best expert here to tell you a few of the examples and projects he's working on in the industry field.
Thank you for the kind words. Yeah, but the industries, basically where you find heat is waste heat streams is typically in the energy intensive industries, as you can imagine. Of course, cement, we highlighted already, is one of them. But when we look, for example, in the glass industry, every glass furnace, either in container glass or float glass, you have before, after the filter, or before and after the filter, some exhaust gases, which you can capture, which we capture already, and produce then some electricity out of it. In the metal industry, both in non-ferrous metal like zinc production, for example, with references, but also in the steel industry, you find, I would say, both gaseous and liquid, sometimes even steam heat sources. Gaseous heat sources, for example, on a reheating furnace, where you have several hundred degrees C, which you can capture, or we can capture and produce some extra electricity with it. But also we see a lot of cooling processes. So there are, as of today, they cool down actively some process streams or some equipment which has to deal with high temperature material, and they invest actually electricity with some air fans or air coolers to basically get rid of the heat. So they pay money to get rid of the heat. And we actually use this heat and produce electricity and also cool it down. And this is, of course, a very nice business case here as well. We have some excess steam streams, for example, on the zinc industry. And then they're one of the biggest heat streams you find in all related to, I would say, petrochemical and oil and gas industry, both up and downstream. If we're looking in refineries, they have several times the heat available on one plant compared to a cement plant. So we are talking here about 100 and more megawatts thermal, which are distributed in different cooling and condensing circuits, which we are already addressing, and especially with our cooling applications, they get very interested in this and trying to build up here, I would say, a similar customer base than, for example, in the cement industry.
Okay, well, thank you. No, that's something that perhaps in the cement industry, when we think about waste heat power, we don't think about all of those other opportunities in the supply chain. So just looking forward a little bit, where do you see the challenges and opportunities in the next couple of years? And then maybe also you could tell me a little about where you see the business or the technology going in a slightly longer time frame.
I think we did quite okay in translating the power plant technology into a product and make it easy, as you said, buying a car just instead of building a house. I like that example. So we also did standardize how we get the heat from the application into our system. That is by means of a hot water circuit, which is also the same design principles, very easy to do. Of course, the different length, etc., is customer to customer different, but the design principles, etc., are all standardized. I think the next step is how to get out the heat from the different customers' processes. This is currently something individual. That is an heat exchanger, which is done individually, and that it's made for this purpose. I think there's a big opportunity to also bring standardization to this element, to make it maybe modular, to sometimes have a little bit over-engineered, oversized, or etc., but also to apply our philosophy to it, saying, don't looking for, let's say, the best technical design, but what is the design that makes the most sense from economical point of view, so that that it even gets more attractive and that it's getting more accepted in different areas, opening more areas and more business cases, because the more business cases, the more market share you can really address with this technology, and the more impact at the end of the day you can generate. And this, again, with our approach, means more volume. The supply chain is driving down the cost, and this is a positive endorsement effect, so to speak. And that's why I think, if you ask me for the long term, I think waste heat recovery has to become, but I'm quite confident will become a standard in many industries. I think we cannot afford to really waste heat on this phenomenal large level that we are doing today if we really mean it to stay within the 1.5 or 2 degrees goal from the Paris climate discussions. So I really think it has to become standard. And if you may allow me, we tried to also generate some picture of that. But if you would be able to capture only in the industry the waste heat and convert it into CO2-free electricity,
only in cement,
then if you would do it in the industry, then you would save about 750 million tons of CO2 emissions per year. So that is really enormous. That means you would have to grow forest in the size of Germany. And if you only would produce electricity from the waste heat in the cement industry, unused waste heat in the cement industry, you could produce CO2-free electricity at low cost level for about 40 million citizens here in the European Union. So it really can be a building block for a successful energy transition that's not, let's say, producing the dilemma of, do we want to have more economic success or do we want to have more sustainability? In our perspective, it needs to be an and, right?
Yes, absolutely. No, I mean, I think that's a very good point to wind up our discussion. I do really like your philosophy of not allowing this to go to waste. Too often I hear people talking about renewable electricity as if it's infinite and free. And of course, we all know that's not the case. We really need to care about energy efficiency if we're going to be successful in reducing emissions. So Andreas and Markus, thank you very much for joining me today. It's been a very interesting discussion and I've learned a lot. So thank you.
Thank you for taking the time and for the interesting discussion. Thank you.
Thank you.
Thanks for listening to the Clinker Factor podcast today. If you've enjoyed it, do subscribe and please recommend us to friends and colleagues and anyone else who you think would be interested in what's happening in the cement and concrete industry around the world. WCA is a not-for-profit company. Please visit our website to see the services that we offer